In this video, we are going to demonstrate how to use a for loop to create arrays and process the information. The particular thing that we're going to do is generate a series of random numbers between 0 and 1 that are uniformly distributed, and then we will calculate the mean, the standard deviation, and the RMS value. As usual, we need to start a new VI, and here is our new VI. First thing that we might want to do here is decide how long we want our array to be, but since I'm lazy, I'm actually going to go to the block diagram first. And in the block diagram, since we're going to be using a for loop, we probably ought to find where the for loop is. They are in structures, but again, you can use the search tool to find them, and they have the clever name of for loop. You can click and drag to make them as big or as little as you want. This one is far too big, but it will serve its purpose. Okay, first thing we want to do is decide how many iterations we're going to have here. So if I right-click on the loop control and create a control, this one is on the front panel there. Probably can put the array length there as the title. Okay, so now I have decided how long I want this to run, how many spots it should go. As long as we've put that in, let's go to the front panel and look. Here is the array length. I want to have a default length of 100, so I'm going to enter 100 here. And now to make it a default, what I have to do is right-click on here, go to Data Operations, and choose Make Current Value Default. Now, when I open up this VI, which I have not saved yet, but when I do, that will have 100 filled in. I could have it be anything else that I wanted. Okay, so now, what are we going to do with these data? Well, we need to generate a number of random numbers, and in the for loop, we can right-click and say, what might be useful for generating random numbers? If we go here to numeric, there is something that looks like a pair of dice. Isn't that clever? And select that. That is our random number generator, and we will put that right in the middle of our for loop. This indicator over here is the loop index, or the loop iteration. So it will start at 0, go 1, 2, 3, 4, 5 for however many there are, so that would go from 0 to 99. And we could go from there to see what's going on if we had some reason to do that. So now we've got, each time the loop executes, we will get one random number. What do we want to do with our random number? Well, we would like to make an array. For loops and while loops have different default behaviors when you put a line in or take a line out, a signal in. The default behavior on a for loop is to concatenate all of the values that you've generated into an array. So if we come over here and click on there, you see that little tunnel indicator, auto index tunnel, that will generate an array of the array length that we have there. So that would be useful, and since we probably just want to look at our array, see if it makes some sense, we will right-click and create an indicator. And since all I want to do is look at it, I'm not going to get fancy. We'll come to the front panel and we will run the VI and see what happens. We have a series of random numbers. If I put 3 in here, I can just double check, make sure it's working. 7. Okay, so that is working fine. And if I right-click and go to Data Operations, I can say reinitialize to default value, and there is my 100. Now, I don't really want this array for anything at the moment, although I could use it, so I'm just going to delete it and go back, Control-E to go back to my diagram. But I do want to take the mean, the standard deviation, and the RMS value from this. So now the question is, how are we going to do that? There are a bazillion different ways to do things in LabVIEW. The one that I'm going to do is I'm going to look here under mathematics, and then I'm going to go and look for a minute, and there's one called Prob and Stat, which is probably probability and statistics. And this one here has a number of things. There's a mean, there's the RMS, there's measurements of the mean. This is standard deviation and variance. Since I'm curious, I'm going to explore that one. So let's take standard deviation and variance and put it right here. And we will put in our array of values. It has mean, standard deviation, and variance. I don't need the variance, but I do need the other two. So what I will do is I will create an indicator with this one, and it's called mean, and since I want mean, that's probably fine. Normally I would right click and do the other ones as well, but I want to do something special with this because the statistics are interesting and I want lots of sig figs on this. I'm going to stretch this thing out a bit, and then I'm going to right click on it and choose display format. And the format string that I've got there, I want to have at least 8 significant figures after the decimal point on this. So I've changed that 0.2 to 8, and we will go there. Now we've got lots of figures. Maybe we want more. I'll right click again, change the display format to, what would you like? 12 is probably plenty. There, we've got 12 digits. I will resize it back down so we don't have all those sticking out. Okay, so now since I've done that once and that was a lot of work, I don't want to do it again. I will just control drag, or again on the Mac, option drag. This for 2 more, and I don't really want mean 2, so I will put standard deviation or stead dev, which seems close enough. And this last one I will call RMS. Okay, so now back to my block diagram, and there's my stead dev and RMS, and I will move them out of the for loop. I don't really want them in the loop. And I'll come up here until I find standard deviation, and then to get my RMS I probably need to right click and see if I can find that. Last time, where was that? Mathematics, probability and statistics, and RMS. Looks good, so we'll put that there. Connect the same array in, and then get the RMS value. If we wanted, we could look at our error values or various weightings or whatever else we want to do with that. But that seems sufficient. So let's run it and see how it works. Okay, the average of a uniform distribution should be right around 0.5, and you can see a bit of variance there. LabVIEW has no problem if we make this 10,000 instead, and then we get awfully close, and 100,000 million almost instantly as well, and you can see that you get the number of sig figs that you expect, and the standard deviation and RMS are very close to what they do. I could then go ahead and save this, as I often do, but I think I'm probably finished at this point with this one.